It's alive. Well, not exactly, but researchers from Washington State University just developed this 3D printed beating heart model. They say it could be a game changer for heart surgeries. And we're joined by one of the researchers on this fascinating project, Professor Kai-Ann Chu. Thank you for being here.
Thank you for introduction. Yeah.
Yeah, where did you get the idea for this 3D beating heart model?
So this idea, actually I have been working on the artificial organ model for years, starting from prostate model, kidney models, and now I'm thinking that many minimum invasive research requires beating models. So that's also we actually discussed with some medical professionals. They really require synthetic dynamic heart model for surgical rehearsal and device evaluation, especially for minimum invasive surgery. So that's the reason we have been developing this model in past 2 years and successfully to realize this for medical rehearsal and surgical practice.
So we're watching video of it right now and it's beating. Can you explain how it works?
Yes. So actually, this model, we have multiple innovation things. So first of all, we use the customized soft materials to mimic the physical property of the tissue and as well as the complex geometries. And meanwhile, we actually integrate the pneumatic actuator into the heart, the wall, to around the pulsations or actually contraction and around have the certain pulsation procedures. And it's actually working well. And also we actually integrated certain sutures into these models to around the entire systems to beating and also the mitral valve for its certain motions.
Yeah, I mean, that's pretty amazing. I read that you did a valve repair on the heart on the heart model. What can other surgeons and professionals learn from using what you've made here?
So we actually did a great edge-to-edge repair, so the valve repairs. So the other surgeon, also the medical students, can actually do the surgical rehearsal using the valves to actually apply implanted into our models. And we can use an ultrasounds and also the customized sensor to evaluate whether the blood regurgitation can be addressed or not. So we show the video that show that after the edge-to-edge repair on our models, the defected mitral valve actually be repaired, and the blood regurgitation almost significantly reduced or mitigated. So that's a great thing that for minimum invasive surgical rehearsal and evaluations.
So I guess I got to ask, how close are you to being able to print a 3D heart that you could actually use as a transplant?
We are also working on the bio things. So this heart basically is for the surgeon or the medical students for surgical rehearsal before the surgery or the surgical, device evaluations. So, but for the heart implantation, we are working on it using a different way, using the bioprinting methods that to around the cells or the beating working on. So it will take us for years, but I think it will not that far. Like a few decades maybe, that finally we can have a real pulsing heart for implantation. That's what I expect, and also make efforts without my team member to working on it.
All right, we are very impressed. Thank you very much, Professor Kai-Ann Chu, for your time tonight. We certainly appreciate it.
Thank you very much. Yeah.